Algebra 1, hey, Catlin back with you here with lesson 10 for your cooldowns. First one this week for Monday. And we're looking at these average rate of changes, which is different than growth factor. We've been talking about growth factor and how we use that to track exponential growth. Like, for example, this time and area of mode problem is a growth factor of 2, double, 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 double. But average rate of change is not putting it into a growth factor exponential graph. It's focusing on what is your average rate of change over a particular time or interval that they ask about. So whenever we're finding rate of change is just another thing for slope. It's just another phrase for slope. They are the same thing. And we know that slope is simply your change in your y values over your change in your x values. So you can subtract the difference of your outputs and divide it by the difference of your inputs. For a function like this, slope can also look like the change in your f of x over the change in your x. So the change in your outputs over your inputs. Same idea. So in this case, not f of x, it's f of d, but f of d are all the numbers on the right. These are all your y's, and these are all the numbers on your left. These are like your x's in the slope, independent, dependent variable. And we're going to find the average rate of change for the whole 6 days. All right, so we want to know the change in the x is just simple. It's 6 minus 0. So your numerator for this one would be, or your denominator for this one would be just 6 take away 0, which is 6. Your numerator is the change in your output, the change in your f of d over these 6 days, which is 64 minus 1. And so our setup for this average rate of change would be how much did it change over those 6 days? And this one would be 63 divided by 6, which 6 goes into that 10 times with 3 left over. So this would just be 10 and a half. So we would get 10.5. We're averaging 10 and a half square millimeters of growth every day, but that's not truly how it's growing. That's just the average that we got in that time frame. All right, so 10 and a half millimeters squared per day is our average. How well does this average rate of change describe how the mode changes for these 6 days? Well, it's not a really good description. It's not great. It's not great. 10 and a half per day is really going to overestimate all of your answers because you're going to be at like 11 and a half and then 20 and something and then 30 and something, then 40 and something and then 50 and something. It's really only going to land on the right one on the end. We're going to say it's not great. It overestimates each day. It overestimates area each day, except it nails it on the 6, except on day 6. Something like that. That's what I would say. And that's just a look at rate of change. We already knew how to find slope. Now we're doing it with an exponential uh, pattern of something that we're adding a linear rate of change to, just to kind of get an idea. All right, what's its average, even though it's not always a great describer of how it's truly growing. All right, see you guys.